Curve C has parametric equations as shown, so x in terms of t and y in terms of t. T is greater than -3 to avoid us taking ln of a negative. We're asked to show that Cartesian equation for C is given by this, a and b to be found. Now normally you just rearrange this, make t the subject, get it in terms of x and put it in. But here we've got a quadratic which makes it a little bit more awkward. So in fact, I'm going to try and make t plus 3 the subject of the left-hand equation, not least because I can see I can complete the square on that t squared plus 6t. So that will give me x equals t plus 3 squared. Then I'll be minusing 9 and minusing 16. That is my starting point. So then t plus 3 squared will be x plus 25, and t plus 3 will be the square root of x plus 25. Technically, I'd get a plus or minus, but because we have to have t greater than -3, there's no way that I could make this minus, because then t would be negative. So take positive root since t greater than -3. And now I can sub this in. So y will equal 6 ln square root x plus 25. We're not far off actually. Then I can write that as x plus 25 to the half and use my third rule of logs to bring that down. So that will give me 3 ln x plus 25. That is in the form required. That is our answer. And the curve C cuts the y-axis at the point P. We're asked to show the equation of the tangent to see that P can be written as shown, where A, B, and C are integers to be found. Now this next bit is not essential, but I think it is quite useful to plot a little graph of what's going on. So ln x looks a little bit like that. It's a good recap, to be honest. It kind of keeps on going forever, but the gradient gets less and less. So if I stretch it by a factor of 3, it will look kind of similar in the y direction. But then the x plus 25 will mean I actually translate it by 25 in the negative x direction. So it will end up looking a bit like that. So we are actually finding, let me just get the tangent. Okay, I'm finding this equation here, tangent at the y-intercept. Okay, for this, we're going to need to use some differentiation. So I can take my Cartesian equation and find dy by dx. The 3 just kind of carries on through, and then when I differentiate ln x plus 25, I'm just going to get 1 over x plus 25, and there's going to be no derivative from the inside to deal with other than 1. So we just get 3 over x plus 25. You could use the chain rule and let u equal x plus 25 if you prefer, but try and get into the habit of dealing with using the chain rule in this kind of way a bit more quickly. So then when x equals 0, dy by dx is going to just be 3 over 25. And we also need the y value. So put that back into this one. We get 3 ln 25. And now I'm going to use y minus y1 equals mx minus x1, or y equals mx plus c if you prefer. You can do that one. I'm not going to show that one. So y minus 3 ln 25 is going to equal 3 over 25 times x minus 0, which is just x. We're asked to leave it in a specific form. A and B and C are integers, so I'm going to need to times through by 25. 25y minus 75 ln 25 is equal to 3x. Very close now. I can just rearrange it to give me minus 3x plus 25y is equal to 75 ln. Now, in the final answer, I want it at ln 5, so I'm going to write ln 25 as 5 squared. And finally, I can bring that power down as well. So my final answer is minus 3x plus 25y equals 150 ln 5.